Okay, welcome. This is video part 2 on limiting reactant. The previous video was explaining it, and here we're just going to work some problems. Okay, so this problem says, find the mass of excess reactant from reacting 14 grams of both propane and oxygen. And of course, because I'm talking about C3H8, I'm going to make sure I do my impersonation of Hank Hill, and Hank Hill sells propane and propane accessories. If you don't know King of the Hill, you need to watch a few episodes and talk to Boomhauer, because I can't talk like Boomhauer, them dang old
Because I happen
molecules.
to sell propane and propane accessories.
Okay, all right.
The salesman of propane and propane accessories.
So, okay, I may edit this out, but we're going to talk about the combustion of propane and oxygen yielding CO2 and water. So the first thing I want to say is it's very tempting for students to say 14 grams. Okay, if I have 14 grams of this, it's going to be 5 times as many grams. And what we use for the balanced equation for is ratios of moles. So I'm going to write a little thing I call a have need. And I'm going to do it with moles. So if I have 1 mole of C3H8, I need 5 times as many moles of oxygen. So where am I going to do this? Let's go up here, and I've got 14 grams of C3H8. I'm going to convert. And if you add up 3 times 12, 36 plus 8 is 44 grams per mole, which is magically the same mass, the molar mass of CO2. Kind of interesting. So if I take 14 and convert to moles, that will be 14 divided by 44, which is 0.318, and I'll go to 4 sig figs for now, 0.3181 moles. So if I had 0.3181, I need 5 times as much, which is 1.591 moles. Okay, let's see if I have that. So over here I've got 14 grams of oxygen, and it's because it's 5 to 1, I know I don't have enough. I don't have enough of that, so therefore it's going to be the limiting reactant. That's just my intuition. Let's prove it mathematically. Well, for oxygen, 1 mole is 32 grams, and 14 divided by 32 is less than 1 mole, not the 1.5 one I needed. It is 0.4375. 0.4375. I better write a mole here, because I've always been insistent upon my students that they show their units and see how the grams cancel. So I've got 0.4375 moles. And if it's a 1 to 5 ratio for propane, I need 1/5 as much going this way. And 0.4375 divided by 5 is 0.0875 moles. The reason I like my have need, in propane, I have more than I need. Okay, so I've got excess. 0.3181 minus this is 0.2306 moles, which I will later convert back to grams. Well, this 0.4375 moles minus 1.591 gives me negative. So let's get rid of that. I had this much, I needed this much, I didn't have enough. So in other words, I'm going to react all of the oxygen because I've got excess C3H8. And I only needed 0.075 moles of it. Therefore, I have, not anymore, I don't have that much anymore. I used all my 0.4375 moles of oxygen with 0.0875 moles, 1/5 the amount of moles, to have excess propane, C3H8. Okay, how many moles will I produce? Well, this first part of this problem doesn't ask that, but I'm going to work that later in a moment. So if I have 0.2306 moles of excess C3H8, 0.2306 moles, the molar mass is again 44. This time I'll multiply to cancel moles, unit conversions, factored label, 0.2306 times 44 should be 10.15. grams of excess, and that's my answer. So I'm going to talk about before and after. I've seen several ways on the internet of people showing this. So one is called a BCA, before change after. So I'm going to write before I had 14 grams of propane and 14 grams of oxygen. And after, well, I got rid of some of that propane. I have 10.15 grams of propane, no oxygen. And then I've got so many grams of CO2 and so many grams of water as products. Again, my answer is 10.15 grams. That's my excess uh, oxygen. So, I'm sorry, excess propane. Excuse me, excess propane, because oxygen was limiting. So, in a 3 to 4 ratio, okay, 1 mole of C3H8 reacts with 5 times as much oxygen. So, this 0.0875, it's going to be times 3 times as much, which is 0.2625 moles. I'll convert that in a moment. And then it's times 4 for the amount of water, which is 0.350. So the molar mass is 44. 0.2625 times 44 grams per mole will be 11.55 grams. And then 0.350 times 18 grams per mole. If you've done a lot of chemistry, you know water's 18 because you've done it a billion times. That's 6.30 grams. Well, guess what? When you add 10.15 plus 11.55 plus 6.30, you get 28.0 grams, which is what we expect from the two 14-gram masses of reactants, a little bit of excess reactant, and some product. So that's this first problem. Very organically written all over the place. So here it is a little bit neater. Okay, now we're going to do another problem. So this is example 2. Find the mass of excess reactant from reacting 91 grams of both hydrogen and nitrogen. So again, I'm going to put a little have, need, okay? And again, I'm going to convert the 91 grams of nitrogen, 91 grams of nitrogen. 1 mole is 28 grams, which gives me 3.25 moles. 3.25 moles. And how much would I need if it's a 3 to 1 ratio? Well, that's 9.75 moles. And you're like, well, dude, I've got way more than that because I've got 91. So I know for now I've got way more hydrogen. Therefore, it's going to be excess before I even, just intuitively, before I do the calculations, which I will prove to you in a moment. Okay, so how much? 91 grams of hydrogen. Convert 1 mole over 2 grams. That's going to be half of 91, 45.5 moles. That's just looking at it. Have minus need. I have more than I need, therefore it's excess. So 45.5 minus 9.75 is 35.75 moles. And I'll go ahead and convert it to grams, which is going to be 71.5 grams of excess hydrogen. Okay, this time there's only one product, and it's a 2 to 1 ratio. So I didn't do the other way. I didn't take this 45.5 divided by 3, which is 15 point something, 17 moles. That's impossible. That's why I didn't even do it, because you have 3, you need 15. We're not the US government where we have 3 and we just print money like crazy. So we can't do that with the law of conservation of mass. We follow some laws in chemistry. Don't make our own laws. Okay, So I'm going to have 3 moles of this and need 3 times as much. So I'm going to produce twice as much of 3.25 from a 2-to-1 ratio, which is 6.50 moles. And the molar mass, I've done this enough. It's 14 plus 3 is 17 grams per mole. And 6.5 times 17 is 110.5 grams of product. So again, I'll do a before and after. Follow the conservation of mass. Before, I had 91 grams of nitrogen, 91 grams of hydrogen, for a total of 182 grams of product. After, I have 71.5 grams of hydrogen excess, and I only had one product, the 110.5. Very simple math. That's why I picked a nice, good reaction like this 132 with simple moles and get ammonia produced, which is 182.0. Again, we follow the law of conservation of mass. The mass doesn't change, it just changes into nitrogen triple bonds into ammonia single bonds, and we still have 2 N's and 6 H's. Very small reaction to balance, very simple limiting and excess. But we've done some other problems. Okay, this is again very organic, and I don't claim to have the best handwriting, but you can see the math work out. And here's a little bit cleaner pick. And you can pause this and look at it. So again, I like that my have more than I need. I have more than I need. I've got excess. I need more than I have, so I can't use it. It's impossible. These are not loves. I just typed XOXO, so it wasn't a number, and you can see that's it's an impossibility. Therefore, hydrogen is excess, and the nitrogen is the limiting reagent, reactant, whatever you want to call it. I call it reactant because it reacts. It's not a secret agent, man, but some people use the word reagent. I think a lot of times they're British. Okay, there we go. There's 2 problems, and you'll do more in my class or work on my program if you see it on the internet. Thanks.